Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 398. Find the number of ways to reach the cave stair. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So the first, the solution is going to be, The solution is going to be, quite a bit tricky, but also doable, right? The idea that I did is with dynamic programming. We'll do another problem or another solution afterwards. I think this is the most intuitive way to think about it. Is that you have the current number, which is 1, and then you go whether we used more than 2 or whether the last operation. Let me type this out actually. So current, just the current number. Pretty straightforward. Use this is the last operation minus 1, and then jump is the current jump counter, right? And I have 2 base cases. One is if we have used, and that means that because if we used it, then we cannot subtract 1, and this is already too big, so we return 0. Because if it's too big, we have no way to get it down, we return 0. If this is not used, then well, we can only subtract 1 time, so also same logic. If it's not used, then we subtract 1, we return 0. Otherwise, we start with total is equal to 0. If the current is equal to k, we plus 1, but keeping in mind that after you reach k, you can reach k again doing other stuff. And this is actually in example 1 and 2. So we want to continue, we don't want to return. And here, if we haven't used minus 1 and we're not at 0, then we just, we do the operation. We go, oh, excuse me. Excuse me. Oh, jeez. We could do current minus 1. And yeah. And true and jump. And that's basically the idea, right? We keep the same. We use the last operation as -1. Otherwise, we just do a jump, which is what the state would be. And then you sum it up. The hard part about this one, I got this relatively quickly. I had an intuition or a YOLO, if you will, honestly, but not sure, right? So used is going to be binary, obviously. Jump is going to be up to, with this constraint, because of jump, we can only go up to 10 to the 9, which is, say, 30, right? 30 times at most. So then the question is, how many unique current numbers can there be, right? And that is really a good question. I don't really know initially, but we can figure it out, right? The idea here is that, and actually this goes into why, this is actually a cleaner version of what I wrote. The version that I wrote is actually this version during the contest. And the reason why I wrote this is it combines basically the used into, so then now we have this thing, right? Let me actually write it. And in here you can see that you can optimize the used out. And the reason why I did this optimization is not because it looked cool, though maybe it is, but it is that some problems, not this one apparently, but some problems actually using it this way allows certain properties to happen and optimization happens, right? And here, the key thing to note for me, and the reason why I chose here instead of this solution, instead of this solution, and a little bit it's just intuitive. I don't know that I thought about it explicitly that hard, but given this one, and everything is the same except for, you have a different base case, and here as well, because here we assumes that we can take a -1, right? The transformation is that after we take a -1, we have to do a jump no matter what. And because of that, then you can only do 2 things. You take a -1 or you don't take a -1, and those are the 2 options. And the reason why I chose this, or it felt more understandable to me in terms of proofs, is because this, for the most part, is monotonically increasing, right? So for me, I knew that in terms of bounds, that this will this will always get much bigger, right? I mean, okay, so if jump is 0, and you can actually change this to this, but because if jump is 0, then this is still going to be plus 0, but jump increments. So you have a DAG, and it's going to keep growing, right? Yeah. And so also the other thing about this to notice is that there is a sort of Pascal's triangle, because then now if you kind of look at this, I mean, okay, so I mean the way that we did this, what can we say, right? Well, the way you look at this, we know that we always add 2 times to the jump. So that means that, technically speaking, this is excessive information. And what do I mean by that? What I mean by that is that you can actually rewrite this to just remove this, right? And then maybe the way that you would clean about that is that you do something like every instance of this, you just add this by jump, or 2 times jump or something, or jump minus 1 maybe because you add 1 or something like this, right? I mean, you have to do a lot of things to be careful because it affects here, here, here. So this may not actually be right, but this is the idea, right? And what I mean by that, right? This is the idea of how in terms of creating an upper bound for the number of operations you have to do. Like if you kind of rewrite this, you can see that maybe this isn't quite right, maybe it's off by 1, but that's not the point, right? The point is that now you could see that here, this is literally just Pascal's triangle, right? Or like this is a very standard DP that you've probably seen a lot of times now that you kind of encode it in a different way. Does this actually work? Maybe this is good enough, to be honest. Oh, no, because then now you have to... I don't know. Yeah, maybe I think this is a little bit wrong because I think we have to handle certain other things. But the idea is still the same, right? Meaning that because of this base, you shift everything from 2 times to jump. And that if you shift all the shift, everything looks like this. And this is literally how the Pascal's triangle look like, right? And if you're not familiar with Pascal's triangle, maybe I should have explained that a little bit. But that's basically the idea. But there is some bound here on here, which is jump, right? So that means that we can at most subtract this jump times, because at some point after jump times, the base case is going to kick off because then it is already too big. For example, if jump is 40, which is a big number, it should be actually even 30. If jump is 30, then this is already going to always return 0 no matter what, right? So then now, because you can only subtract this, you can only take this path 30 times or jump number of times, this actually current can have actually at most jump number of unique, well, technically jump square if you want to be more specific, but they're not, but they're directly related to jump. So because if you add this to 2 times jump, of course the number of actual unique currents is different from the number of unique current to jump pairs, right? So now the number of unique current jump pairs is 30 square, or technically jump square, I suppose, right? So then now that means that this is going to be O of jump square, which is and how many jumps we get? We get actually log k number of jumps. Jump is going to be roughly log k, right? The max number of jumps is going to be log k. So this is going to be O of log square, or log k, log square k, right? Is the time, or well, time and space. right? I guess I'll just add space. So yeah, so that's basically the constraint here. And I just thought that this way is a little bit easier to see the bound, which is why I wrote it this way during the contest. And yeah, and that's pretty much it for this. Because I think you can probably. I'm gonna write it back here. Oops, I'll just delete this. So that's basically the logic here, right? And now with this If this understanding and explanation, there are actually a couple of people whom I believe this is Jan Sean's code. Someone sent me a link because I still cannot see it because this is still during the contest. Like it hasn't counted down yet. The idea here is that let me actually just edit it up. The idea behind this solution is that because it's just taking what I did to another level, right? Because then now, well, we said that we can take jump number of jumps up to, right? So then now we go, I mean, there's actually comments on it. But yeah, let's say, let's say we take one jump. What happens? We take one jump, we take one jump, and that means that we can also take at most -1 or 1 -1s, right? If we take 2 jumps, we can take at most 2 -1 jumps, right? And so forth. So then now what happened? Then now what they did is just brute force the solution, right? Because we try, how many ways to get there with one jump? Well, if at most -1, then we just count. With one jump, you count how many ways are there to get one jump, and then with one jump, there's really only how do I say this? Let's just say j is equal to jump, and 1 is 1 -1, right? So then now, starting with 1, which is where maybe these constants from, then now how many ways are there to get one jump? Well, with one jump, you get a +1 no matter what, right? Because, the 2 to the 0, it's going to have one jump no matter what. So then now, we just calculate, well, how do you get to k, right? Well, it just depends what k is, right? So plus some, I guess in Jan Sean's lingo is v, but plus v, let's go this v then, yeah. Plus v is equal to k. So then now we solve for k. Well, yeah, we have k, so then now we solve for v, and v is just going to be k minus 2, right? Well, v is -1, so it's v times -1, sorry. If you want, depending on how precise you want to be. And then now, if you have that answer, then now, the idea is that, how do I say this in a proper way? Sorry. And then the way is that, there are, so we need v -1s. So then now the rest of the problem just becomes a combinatorial one of, let's say we have j and v's. So then, and let's say we have one v, right? Maybe, maybe let's say k is equal to 1, so v is equal to 1, and then now we have two combinations, right? Because we have jv and we have vj. So this becomes and you always have this j, and then you're just trying to figure out where to put the v's, and in this case there are 2 of them. So then it becomes whatchamacallit? Becomes what do they call it? Like stars and stars and stripes, is it? Stars and no, what am I always stars and bars. Yeah. Then now you get stars and bars, right? And then that's where this formula comes from. And then to give a better example, or like another visual example, is that, and then you kind of loop this over this one, right? Because now, what happens to 2 jumps, right? How many ways, or I'm just going to skip ahead a little bit with, say, 5 jumps. Well, 5 jumps, you start at 1, you have the first jump is going to be 1, the second jump is going to be 2, the third jump is going to be 4, right? Powers of 2s, right? And of course, this number is just equal to 2 to the 5 minus 1, right? You can also think about this in binary, right? Which is that this is 1, this is 10 in binary, this is 100 in binary, 1,000, 10,000. So this is 1, 1, 1, 1, 1, which obviously is just 2 to the 5th minus 1, right? Or 2 to the 5th minus 1, right? Pretty straightforward, hopefully, right? But then now, okay, so then now you have this. This is the number. This is the base number. This is where we end up with no v's, right? With no negative ones. So then we have, and it's kind of funny actually, because then now it actually adds up to 10,000, or so because if you add 1, then now it becomes 2 to the 5th, right? But then now as we said, plus v times negative 1 is equal to some k. So then what happens? Let's say I don't know. Let's say we need 5 v's, right? Or let's say we need 3 v's, or 3 negative 1s, which is 3 v's, and we have 5 jumps, right? 5 jumps. So then now we just have 5 jumps, and the v's can be anywhere before. Let me actually put under to make it clear, right? So then now we have 6 spaces for the j's to fit, or for the v's to put. So we have 3 v's to put in the 6 spaces, and that's of course 6 choose 3, right? And that's basically the idea about the solution. And then you just do a for loop for k. They use j, so it's a little bit confusing because j is what I set for jumps. But let's change this to k is not right either. Say d for digits, right? No. This is the number of jumps. No. This is right. Sorry. Yeah. So then, how many ways are there to get to j jumps? And that's basically the idea. You do j jumps. You have this total. They did a -1, which, yeah. I mean, I'm sure the math is right with the if statements. I mean, I don't know. You can double check it. And then this is the idea about the total minus k, which is how this kind of figures out, right? So yeah. That's all I have for this one. Let me know what you think. And obviously, this is all of d. I guess technically d squared, where d is the log k, right? D is the number of digits. Because if you really want to be precise, this is all of log k loop. This is an O of log k operation. This is going to be O of log squared k. So it's the same operation. And I think this is actually, I don't know. I mean, let's just say I think this is also log k, to be honest. But yeah, or this is j. Okay, let's say this is a j loop. By the way, this entire thing is going to be the same complexity. Even though it looks much tighter, this is actually the same complexity, which is kind of crazy, right? You analyze it correctly. I believe so. If not, leave a comment. Let me know what you think. But that's all I have for this one. Let me know what you think. Thanks for watching. And you could watch me solve it live during the contest now. No silly mistake, please. Find a number of ways to reach the cave stairs. You're given a non-negative integer k. The existing okay. Lowest stair is 0. Alice has integer jump from 0, starts at 1, and when we she go down to stairs I minus 1. Okay, maybe. Go up to the stairs I plus 2. What is jump? Oh, it's initially 0. What is k is something big, huh? Interesting. Also interesting. I mean, you can only use jump like 32 times or whatever. So can I just do DP? DP count? No, I mean, you can't do count, obviously, because it's 10 to the 9th. But I minus 1. Well, this only happens when you've never done jump before, right? Then you do a minus 1 plus 1, so we don't have to worry about that case. So that is actually, I don't know why they tell you this one. This one is actually, I don't know. All right, what is k? K is the number of 0. Oh, do you start at 1 always? So she starts at 1. Okay. Okay. This is a very weird problem, for sure. So there are really only two things, right? You can either do a jump, or you could do this and then do a jump because you're forced to. So that means that there's probably not that many possibilities. Am I right in that? I don't know if I'm right in that, but I hope I'm right in that. And if jump is greater than k, which is after 30 jumps, then yeah. All right, let's try something dumb, and then we'll see. Current jump, right? Then we return go 1 0, and just cache it for obvious reasons. And then now, I think these are all the weird cases, right? Let's see. Okay, so you can. Alright, if current is equal to k, then that's not even enough to return, right? What is the thing? So if jump current minus 1 plus 2 to the jump is greater than k, then we return, right? Oops, what did I do? Then we return, right? Otherwise, we just do two things. We can do well, just what I did. I don't know. Is this? Am I too dumb? I don't know. I mean, maybe. I'm pretty dumb. This only goes like 30 deep, but what am I doing? Oh, I don't return. Yeah, I mean, that's the wrong answer, but at least it's wrong very fast. What I want to know is actually the running time. We could debug the edge cases, but that's actually shocking. Well, but that shouldn't matter. I mean, that's fast, actually. Faster than I expected. Okay. I mean, maybe returning 0 is very easy. Or maybe it's just impossible to reach these, which is maybe fair. I don't know that that's... What is a number that we can reach? 2 to the whatever, 2 to the 29. Well, that's not good. Oh, no, because it's 1. No, but you could remove it. I mean, it's doing a lot of stuff. Alright, let's get rid of these two for a second. So maybe it's time to debug these. Maybe it's fast enough, I just need to debug it. Okay, goes 1 0. Let's do a post 1 0 1. Okay, let's do the K here. Okay, so why is K 0? Because oh, I don't. Can I just special case these? I don't even know. Okay, so it goes to 1. That's 1 count. Alright, let's do the 1 first. 0, maybe we can. I don't know if this is true that I can special case this, but this one is still wrong though. Alright, let's see. Oh, you can subtract 1. Okay. Yeah, okay. I can see that. It doesn't give me the right answer though. Still. Oh, because it's an or. Because basically, that's what I want, right? But I guess this terminates before. Oh, because current is greater than 0. Whoops. Well, no, you can't do this move. But we also don't want it to return. We just can't execute this. So actually, we want to return it here, and we return total. This is a very weird base case. This feels like a problem that I'm gonna have like 20 wrong answers on. Okay, why is it 3? Which 3? Oops. Alright, what's 2? What do I think 2 is? I think 2 is 3. What does my book say? 2. We do 1. Okay, that's 1 step. We go to 2. Or we do the dupe. We go to 1, and then we do. That's 2. What is the third way? We do 1. Third way is start at 1, go to 0, we add 1, we go to 0, we add 2. What's the third way? Is this right? And this is an annoying problem. This is a problem that like I feel like I could get, but will take too many wrong answers. I'm trying to avoid wrong answers today. One is 2. Is that true? Why? Is this even right? I don't know what the base condition is it? No, this is not right. This just means that we don't do this. So we can do rewrite this as this. What is the base case, Larry? Base case is if this is the base case is if current -1 is greater than k, then we just return 0. Maybe that's the base case, because you can't get smaller. Okay, so now it's returning 4. Is that 4 right? I don't even know if that's right. I think that's the problem. Let's see. I mean, alright, now at least I don't need this. So that's good. Is 2, the answer to 2, 4? Why? So 2 with 2 jumps is 1? How? Well, because you're already at 2. Okay, fine. That's actually obvious. Okay, you're at 3. I don't know. I just got YOLO. I think I spent more than 5 minutes on this. What is going? I don't get. I mean, I spent a lot of time on this because I just didn't like. Huh. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this review, everything in between. Stay good, stay happy. Yeah, to good mental health. I'll see y'all later and take care. Bye bye.